Hi, welcome back to the breadboard. In this video, which is part 3 of I'm not sure how many, we are going to look at the industrial sensor node from STMicro. This is the STWIN-BX board. It has quite a few sensors on it, as well as the option for battery power and extension sensor nodes and adapters for different boards as well. So we won't be using these in our proceedings, so I'm going to move these out of the way. And I probably won't be using the battery for now in these experiments. Nevertheless, we will be using these other things. So the board, let's bring up the datasheet first of all for this. So now we're on to the STWIN.box, which is the SensorTile Wireless Industrial Node Development Kit. And there is a lot of things on this board. So features this board: multi-sensing platform, vibration monitoring, ultrasound detection, it's got core system with processing, sensing, connectivity, and expansion capabilities, ultra low power Cortex M33 with a floating point unit and trust zone running at 160 megahertz. It's got 2 megs of flash. There are some videos here getting started on high-speed data logging and industrial sensing in a tiny box. Now there's a whole series of videos on YouTube, which we will have a quick look at some of them, which take you through getting started installing software and things like that. I'm not going to play every one, but I will link them. And if I look at my notes that I put together, wherever they are, got all of the videos for this, the STWIN.box. So requirements for the STWIN.box. I have some of this up here. You got that? Yep, that's what we're looking at. So I've gone through a lot of what's in here already. This is links to all the data sheets for all the individual components and things like that. Description, which we've pretty much gone through. Solutions overview. So we can see here we've got our STM32U5, which is our core processor in here. We've got the Wi-Fi. It shows an RS485 interface here, but the chips are not populated on this board. NRFC ID tag, that's in here. The USB, Bluetooth, the safe chip, which is like an encryption chip, I guess. It shows the interfaces that these are all connected to as well. As you can see, there's lots of I2Cs and SPI buses and things as well. We've got the vibrometer, the 6-axis IMU, 2-axis accelerometer, a 3D accelerometer, temperature sensor, 3D magnetometer, pressure sensor on I2C2, low noise, low distortion op-amp, analog to digital conversion, analog microphone, digital microphone. And a few extra things thrown in for good measure along the bottom here. USB-C interface as well. So let's just keep going quickly. You can read detailed through this to your heart's content. By the way, if you search YouTube for ST eval $STWIN-BX, etc., you won't really find it. I think that should be a dash in there. So getting started here. It does have some warnings that you shouldn't be charging the battery outside of 10 to 35 degrees C, detail to what's in the package. So this is that 34-pin cable. It's double-sided on one end and single-sided on the other. Layout of the board. Again, everything that's on it. I will provide some high-resolution pictures when I post everything. Alright, assembling the STWIN-box. So I haven't assembled mine yet. I will assemble it into the box, but I'm not going to be connecting the the battery at this point in time. And what I'm more interested in is, I might actually leave it out of the box for now, but what I'm more interested in is connecting it to the programmer. Now here's using one of those 34-pin cables to connect to a separate 24-pin DIL connector, which is a way of connecting to some of the sensor options that are available to extend this. Now I'm not 100% sure that I actually need to use the programmer for this particular board. All right, so we're getting into programming. So STM32Q Programmer using the USB mode. What other modes are there? External debugger. This is an earlier version of the STM32 Programmer. Mobile app. Anyway, lots of different ways. We're just going to look at the USB way right now. Oh, while we're at it, while we're here, what they're showing here, you get this little pack of stickers. And if you're going to use this board in a slightly harsh environment, dusty environment, humid environment, you might want to protect the MEMS microphones from ingress of crap that would destroy their functionality. So they provide little stickers that are acoustically inert, but they will prevent dust and things getting into the box if you have it all sealed up in the box. Okay, so we've already put the programmer in, the software. So it might ask, well, we will go through the firmware upgrade on this one as well. So I guess let's just unplug this. We need a USB-C cable this time. For this new board I have, this should be a lot easier. Okay, let's switch to the different view. I will talk through this, but you can read this yourself. I will be linking all of the documents in the video. So looking at this board in a bit more detail, I guess. I'm not going to point out every single chip. The tech manual that I was just going through has the layout of all the chips, but a lot of the MEMS sensors are all over here, not over here. This is power management and things. The microphone and things like that is here, and then on the other side you've got another microphone here and a few other chips and things as well with different sensors and accelerometers and things. This cable here, this connector here, is what you plug this into. This cable here to extend to other boards. We'll be using that a little bit later. This is not an inductor for power management. This is actually the NFC antenna. We have our memory card reader and a few user buttons and reset buttons and things here. Anyway, this is the board we're looking at. We're not really going to play with the Wi-Fi or the Bluetooth right now. We're going to play with a couple of sensors just to get a feel of how easy it is to get going with this board. So first things first, unplug that little protection cover for the USB, and when we plug this in, we should hear the computer detect it. It says press the reset button, and while keeping the button pressed, press the user button, release the reset button, release the user button. It started in DFU mode, which is where you'd hear it go bleep on the computer. And then on the Q programmer, we select USB mode. I guess first things first, we'll press the reset button. Which one's reset? That's the middle. So this one's reset. And this one is the user one, so it says press reset. Press and hold the user one, and let go. It should go into DFU, and you heard the PC there go bleep. So now we can let go of that. Now I think we're in DFU mode, and if I go back to the screen view and fire up the software, it should find it because it's in DFU mode. It found it this time. Had to fiddle around switching in and out of USB up the top here. So it's found it. So what does it say? Let's go and read our description again, see how we continue with this. So we've done that. USB, USB 1, Cube programmer, select USB, device memory. I guess that's confirming that we're talking to it, which we are. Erasing and programming tab. So what we haven't done yet is downloaded, I guess, the software for this. It's not doing it right off the bat. Let's have a look to see if there's any other information in here. Okay, once the hardware connections are in place, you can either download one of the sample application binaries provided using the STM-Cube programmer, or you can recompile and do your own thing with the IDE. We're going to use the programmer. Let's go here. I am guessing at this moment. All right, now I happen to know, so I've never looked at this before today, but I did watch a couple of videos. So let's minimize this and go have a look at a couple of videos a second. All right, this is on YouTube. I'll provide the links in the description. And I'll make this full screen. I'm still stuck in the corner, shouldn't be in the way. Okay, so you can watch all of that at normal speed yourself if you want to. So the main thing we need to load, go back to it, is the FP-SNS DataLog2 and Python and Unicode. So I'll leave that there. IDE I've already downloaded, so FP-SNS DataLog2, FP-SNS DataLog2, so in here, function pack. Right, so it looks like I just have to access that. There's nothing, STWIN.box examples. All right, Notepad++, let's just quickly install that. Install Python. Obviously, the speed of your installs may vary depending on your computer and things and your download speeds. I pre-downloaded all of these. So done, so we'll just close that. Data log is already expanded up here, so it's okay. EMS evaluation kit package for Windows, get latest, accept. And it's still doing that to me. Okay, so I don't know why the STM website is acting up, but the last couple of days it's been giving me 404 errors and I've been trying to download software, even though I'm logged in. It may fix itself in the next couple of days, so hopefully it will. But I do have all the software downloaded, so we'll continue. So if we go to just before the error, you can see here we've got for Mac, for Linux, for Windows, and that's the part number STSW Mark 1 MKI 109W. So if I go to my download folder, that would be this one. So we'll go in here, Unicode for Windows, and we'll just run setup from here. Accept the agreement. This should be quick to go through. Oh, yes, create a desktop shortcut. Okay, just make sure that launches, and it does. And we'll close that for now. Let's go to the next module, which I think should probably be linked. Right, connecting and flashing the STWIN.box board using DFU mode. That's what we want right here. So we'll see how easy this is. I find it much easier to watch a video and then try to replicate it, and that's exactly what I'm going to do right now. So we'll go in here.
Holding the user button, connecting.
Remember from the previous description, you can also, if you've already got it powered up, you just hit the reset button, hold it pressed, press the user button, hold it pressed, and then let go of the reset, and it'll achieve the same thing. So we pick USB, hit refresh, comes up USB 1, comes up with a serial number, so that's all perfect. Now it's starting to talk about erasing things, so let's play this a little bit more. Way down the bottom here.
When prompted, click OK to continue.
So yeah, we want to erase the chip, so down here, make sure you want to erase the full flash chip memory. We'll say yes. I thought we did connect. Okay, connect. There we go. Now we're connected. Try that again. Yes. And you can see the whole memory is now FFFFs and things. So that's good. Let's go back.
Click the download icon at the top left of the screen. Next to the file path box, click Browse. In the File Explorer window, there's Navigate to C:\/ST.box data log workshop. Oh.
Now mine's in a different location. It's not in the root directory. It's under Capture, WURTH, Program Downloads. STWIN data log. Do I not have that? Did they not ask me to download it? Just have a look here. STM function pack data log 2. Okay, so I'm in the right place. Version 3.1 I'm in. Yeah, that's a much earlier version there, but it should still work.
Open the data log 2 folder. Open projects.
Let's go back and have a look. Data log 2, projects, okay, I'm there.
Open the STWIN.box folder. Open applications. Open the data log folder.
All right, so STWIN.box, applications, data log 2. I think it's going to go to binary here.
Open binary. Select the data log 2 binary.
All right. And they're picking the release one. So I'll say open there.
If you have a debug this version in the folder, please choose this version. Click open. Ensure the start address is set to 0x08000000.
Here it is.
Click the Verify Programming checkbox. Click the blue Start Programming. After a few moments, you should get a message that the board was programmed and verified successfully. Click OK to dismiss both messages.
Yep.
Close the Q Programmer application.
We're done with this for the moment.
This module activated updated the firmware for use in the next module.
So that was module 3. Now we're going to go on and do module 4, which is capturing sensor data over the USB bus. All right, this is all a precursor to capturing data when we're running the motor and the motor controller and things. It's just exercising the WIN-box board so we're a bit more familiar with it. So let's continue and we'll do that. I'm running the videos at 1.5 times speed because I can still understand it, and you can watch it yourself at your own time as well. So I'm not too worried about me capturing all of the data. I'm also interjecting so I don't get copyright strikes when I post the videos. So let's continue on the next module. So this is where we start using Python to do a few things, command lines. They don't provide, or I haven't seen where they provide like workshop notes where you could grab a copy of the command line and just paste it. So I will provide those in the write-up. It's a pain trying to get these long command line things all going with the right switches and stuff like that. So I will help you out by providing it.
Underscore data 2 underscore 1.0 /utility /ST score.
So it looks like I don't have this file yet. It hasn't told me where to get it from, and the previous videos did not tell me where to get it from either. So let me just do a quick Google to see if I can find it. Okay, it's a good job I did some ahead research, because it looks like I already do have the function pack downloaded and expanded. And can I find out where the link was that I originally got it? No, I can't. I will try and find out when I do the posting so that I can link it in with the video and everything for you to be able to get it yourself if you need to. So let's continue and see where we get to. It's, oh, the file, by the way, that you need is, where is it? FP-SNS-datalog2 is the file. Like I said, I will provide the links in the description. Sometimes things can be a little challenging, so yeah.
Config score Notepad ++ to open the device config file. Right-click on the device config.
So device config.json. Let's go see if I can get that. STWIN.box _config _examples. STWIN.box _config _examples. Okay, device config JSON. That one. Now let's see if I can open with Notepad++. Here we go. So, guess I need to expand that a little bit for you to see it. Let's go back to the video and see what it says we need to do.
JSON file and select edit with Notepad++. You now scroll through the contents of the JSON file. Edit as needed. Device configuration file contains.
So as a quick note, let's go back to R1 here. Hopefully you can see that okay. For each device that is in here, there is an enable. So this first part I don't think is the devices. Here's the tags. We've got a tag, enable true, tag 1, tag 2, tag 3, tag 4. So a whole boatload of tags that you can turn on and off. Right, here we're down to things like Wi-Fi config. So you could put in your SID and your IP address and things like that. So here's a accelerometer, enable false, and you can obviously set enable true if you need to. Magnetic sensor, pressure sensor, microphone. You get a whole bunch of parameters you can set for all of these things. I won't go through all, you can have a look yourself. So let's get back to the video.
Sensor descriptor, onboard sensor. Characteristics such as the full-scale setting, sensor output data rate can be modified from this file. Output data rate, or ODR, is the rate at which the MEMS sensor will supply new sensor value.
So underneath the heading of each section, you've got this ODR piece here, which is showing us exactly what he's talking about. Output data rate. So this is set to 3 on this one. Output data rate set to 7 here. So that's what that's a pressure sensor. So this bit is just to make sure you turn all of the sensors off initially. So what they're doing is they look like this one, the pressure sensor is turned on out of the gate. So we're going to just copy that. Control H is find and replace. So we're finding all of these trues and we're going to change it to say false. And we'll do a replace all. That's 6 occurrences we did there. And that's what this is telling us to do.
Click replace all.
So they found 6 as well. So if you find that, that was roughly line 190. Obviously not anymore. ISM 330 is what I'm looking for. Probably easier to find it. ISM 330. Is that the same file? DHCX_ACC. DHCX underscore, yeah. So this is in line 395 on mine. There's obviously a lot more been added to this file. This was line 190 in their example. So you can't always take exactly their word for it. You're going to have to do a bit of searching. So we're going to change this to true to enable it. So you can see using 9, which is what the default is very fast sample rate, because that's 6,660 samples per second. We're just going to drop it down to, I think they said 104. So 3 will be written there. So let's go do that. We're here, we've just changed this to true. We need to change this to 3. And do file, save as. You don't want to overwrite it. It wouldn't harm if you did overwrite it. So we go up 1 layer. Okay, I don't see an HSD Python in here. Well, under mine, I've got CLI example. There's no other. So it looks like I'm using command line example now, not the one they mentioned. Just save it there. Everything else looks the same based on where they saved it. It's just they seem to have moved the locations and the videos are not up to date. So you can see here the command line is getting long and lots of switches and things. I'm skipping a bit here.
Prior to start the tag.
All right. Close this. We're going to open a command prompt. Command prompt. And I happen to have made a note, I think. Capturing sensor data over USB. All right, so configure the sensor using JSON, config using, and here. So I'm in the example, so there's the command line I made up for this, so I'll copy that. I'll post this information for you as well, of course. Okay, we have gone through updating this sensor board with some pre-compiled software, the release.bin file that we just uploaded in DFU mode. Now, one of the things that we discovered is that if you take the default files and download them and everything else, they do not match up with any of the videos. But there is a documentation file I found with getting started which seems to deal with that, and we'll have a look at it in another video. I think this video right now is getting a bit long. We've got everything installed and running with this board, and it is now streaming data. So what I want to do is close this video off and open or start another one to show how we can do data collection. But instead of going back to software that was obsolete several years ago, I'm going to I've done it already once, so I'm going to do it for real this time. We're going to use the latest software and make adjustments for using a separate Python SDK that's been set up. It's all been extracted from the original SDKs and separated, so we're going to try and use that. But it does mean that we're going to need to install Python, I think, which we've already done. If you haven't, it's straightforward setup. But you also need to install, in the case of Windows, the Get Desktop so that we can download the repository. And the way the repository is set up, it has expansions. A lot of them, nearly all of the folders are empty, and they're actually linked to other repositories, so you have to download them in a certain way. I tried just downloading them by right-clicking on the repository and say zip it up and send it to me, but 90% of the folders were just empty and useless. So after doing a considerable amount of research and testing and evaluating and things like that, I feel that I'm now in a position to be able to move forward with the current software. It's a little bit frustrating that STMicro hasn't updated their videos and made it clear in the documentation the consequences of using the videos that are floating around with the latest software that you download. It doesn't warn you. When you go to GitHub and you look at the repository for this, for the DataLog2, the newest version is 3.1, but the version of the videos and everything that I've seen, including the ones that are still on the ST.com website, are all referring to version 1.1, which is back in 2023. That doesn't sound like a lot, but that's quite a few versions. I think it's about 10 versions. Anyway, so let's just call it quit on this video, and I'm going to start a fresh one with using the latest software, installing the repository, installing obviously Get Desktop so that we can get the repository, and then try and run some of the examples, because there's some really nice graphical Python examples which could be used. The names have changed. We'll use the same video slash text from documents, but we'll adjust it for the latest files. And we'll see if we can get it working. Pretty sure we can. Anyway, that's it for this video. I'll see you on the next one.